Hi everyone, I hope you are doing well. So today in this video we are going to solve January daily Leetcode challenge. So today's problem is minimum number of records to burst balloons, right? But before proceeding further, make sure to subscribe my channel. It will really motivate me to create more such content for you, and make sure to join our Telegram community as well. You can follow me on other platforms too. The link is there in the description. So let's get started with the problem statement now. The problem says there are some spherical balloons tapped onto a flat wall that represent the xy plane. The balloons are represented as a 2D integer array points where points I equal to x start comma x end denotes a balloon whose horizontal diameter stretches between x start and x end. You do not know the exact y coordinates of the balloons. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x if x start less than equal to x less than equal to x end. There is no limit to the number of arrows that can be shot. A short arrow keeps traveling up infinitely, bursting any balloons in its path. Now, given the array points, return the minimum number of arrows that must be shot to burst all balloons, right? So basically what the problem is saying that we are having balloons, right, which are getting represented as a 2D integer array, which is named as points, where point I represents what x start and x end, now which is representing what the horizontal diameter of a balloon, right, that stretches between x start till x end. Now we are not sure about the y coordinates of the balloon. Now they are throwing some arrows which will be shot up directly vertically in the positive y direction now, right? So a balloon would be burst by an arrow shot only when this range that they have provided, right? So only when we shot arrow at x, and this x value should lie between this range x start less than equal to x less than equal to x end. Now there is no limit to the number of arrows that we can use, right? It will be keeping traveling up infinitely, bursting all the balloons that come across in its path, right? So we have been given the array, we have to determine the minimum number of rows that should be shot to burst all the balloons, right? Okay, so here you can see, here's the first example. So this is the points array that we do have. Now for this one, we are getting the output as 2. So here's the explanation. The balloons can be burst by 2 arrows. So how? If we shoot an arrow at x equal to 6, right? If we are taking this value x equal to 6, so how many balloons would be busted? First this one, because see this x is lying between this range, right? And the next is 1 6, right? That will also be bursted because see this 6 is less than equal to 6, so this is also lying in this range only, right? and shoot an arrow at x equal to 11. In that case, what balloons would be bursted? This, the balloon lying in this range, 10 comma 16 and 7 comma 12. So minimum number of arrows required is 2. Now here for this particular example, you can see one arrow is needed to be shot for each balloon for a total of 4 arrows, right? For this one, for this one, for this one. Now if you will properly observe this array, right, so they are not sharing any portion. This is completely separate with that one, or like any para we cannot do. We overlapping नहीं, there is no such overlapping between the values that we're having, right? So for each balloon we need 4 arrows, right? Now one arrow needs to be shot for each balloon for a total of 4 arrows. Okay, now here if you will see, right, so here the minimum number of arrows needed is 2. So here you can see the balloons can be burst by 2 arrows. So if we are taking x equal to 2, right, so how many balloons we can burst? First this one and this one, right? Because this x is lying in the range for these two one. Okay, and if you're taking x equal to 4, so how many balloons, like we can, these two would be bursted with x equal to 4, right? So minimum 2 arrows we need, right? So I hope the problem statement is now clear for you, what the problem is actually asking for. Now the next thing comes is to think about it, like how we can solve this problem. One thing while discussing the problem, you must have seen that uh, there is a case of overlapping. right? I believe most of you must have solved such problems where we have this overlapping scenario, right? If not, then definitely you'll understand in this problem, in this video, like how we can approach this kind of problems, right? Okay, so what we can do, first of all, think, like for example, we took this example, right? So here, basically, first thing to observe here is that you don't need the value of x, right? You need the count itself. So how you would be determining, like what, how many minimum number of arrows count that I need to burst all balloons? How you can determine this? Let's say, okay, let's understand. So here, let's say we have this array, right? So if I'm choosing this one, 1 6, right? If I'm choosing 1 6, let's say I have, okay, at least one arrow we need, right? That is for sure. One arrow you need, okay? So I took one arrow for busting this one, right? Next I chose this one, 2 8, right? Or basically I'm just lining up. See, I'm just lining up these balloons, okay, in a sequence. So 1 6, I took one arrow for to burst this one, right? Now just think about it. Let's say when they were explaining, they took x equal to 6, right? They took x equal to 6, and for this they covered, okay, we can short this one, we can short this one, right? For our arrow, if we are taking this value x equal to 6, right? Now how you can determine this? When you took this one, for this one to short this, to burst this, you need one arrow. Now don't you think how you can say that I can burst this one too? What it is actually depending on? This range, right? Like the last range for this one, the arrow that you must be choosing, right? It should be in this range only, 1 to 6, where 1 and 6 also must be included, right? So if this value that we do have, right, if this value that we do have, right, and this value, the other balloon that you are choosing up, right, if this value, the next value that the next balloon that you're choosing up, the starting value of that balloon, the coordinate value, basically what I mean, if it is, what, if it is lesser than that of this value, we can say, right, that this arrow will burst this one also. What if this value is larger? Then obviously we need one more arrow for that, right? We need one more arrow for that. What would be the best thing? If we can just line up with these balloons in a sequence, or we can simple terms, what I can say is, if we can sort them, okay, sorting. Now how are we gonna sort this? How are we gonna sort this? Like which element is playing an important role here? The last one, right? The end coordinate. So what if I'm saying just sort this array on the basis of end coordinates? So if you're sorting this on the basis of end coordinates, so right now what do we have? 10 16, 2 8, 1 6, 7 12. Now I'm saying to sort this on the basis of end coordinate. Then what we'll be having? 1 6, because 6 is the smaller, so this pair first, then this pair, 2 8, then this pair, 7 12, then 10 16, right? Now at least one arrow you need for sure, okay? So we'll be taking one variable to keep track of the count, and we'll be initializing this with 1. At least one arrow we need for sure, okay? Now what we'll be seeing, the next element on which you are moving on, if the starting point of this element is greater than that of this value, which we have seen previously, the end coordinate which we have seen previously, if it is, then increase the count. So right now the count is 1. So is this condition true? No, right? 2 is lesser than, obviously, from this one, right? Okay, fine. Okay, now we'll progress further. Now we'll be checking for this one. Now this is what, this is obviously not in the range. 7 is greater than that of 6, so we'll update the value of count as 2, right? We'll update the value of count as 2. And now the end coordinate which we'll be focusing on is this one, right? Okay, is this one, 12. Okay, now next element is this one. Now again we'll be doing the comparison, so here also we'll be checking. So 10 is less than that of 12, right? 10 is less than that of 12, so we don't need any other error for that. So what would be the minimum count for this one? 2, right? Now let's take this one also. So 1 2 3 4 5 6 7 8. So here this is already sorted on the basis of and coordinate. If you will arrange it, so this is already sorted, right? So again minimum count, at least one arrow we have to take, right? So 2 we'll be having here. Now we'll be comparing, so this and this. So obviously 3 is greater than that of 2, right? So we'll be updating the value of count as 2, right? now now what element we have to focus on, or basically to keep track of it, we'll take one more variable. Let's call it as prev. So before it would be 2, now it would be updated with 4, because now the next element we need to compare with this 4. So we have 5, 5 we have to compare. So 5 is greater than that of 4, right? So it means we need one more arrow. So count will be updated as 3. Now the and coordinate which we have to focus on, or which we have to compare with the next element is starting coordinate, which this is going to be 6. So we'll be updating this with 6. Now again we'll be checking it. So 7 is greater than that of 6, right? So we'll be updating the value of count as count plus plus, that would be 4. So we need 4 arrows for this one. If you want me to take one more example, let's take the last one also. If it is want 1 2 2 3 3 4 4 5. Okay, it is 1 2 2 3 3 4 4 5. Luckily this is also sorted. Okay, this is also sorted on the basis of and coordinate. So here count, that will be 1. So again we'll be doing the comparison. So this element and this one, this is not getter, right? This is not getter, so we won't be doing anything. Next we'll be coming to this 3. 3 is greater than that of 2. This one, right? We have seen, right? It is greater than that of 2. So we'll be updating the value of count as 2. And the element that we have to focus on now is, like previously prev was 2, and now it would be updated with this 4. Prev equal to 4. Now again we'll be doing the comparison of this one and this one. We'll be comparing. So 4 is equal to that of 4 only, right? So we are not going to make any change, right? So the minimum count for this array is going to be 2. Okay, so I hope the problem statement is clear, the logic is clear. So what we discussed just now, right, we'll be having a code for the same. So here's the code for the approach that we discussed just now, right? So here first we are sorting the array on the basis of and coordinate, then at least one arrow we need, right? And prev value we are initializing this with 0.01. Okay, now first element we consider, right? Now we are taking our loop from int I equal to 1 till the length of this array I plus plus. Okay, this I'm gonna remove. Okay, now here what we're doing is we are simply checking that if the start coordinate of the balloon, if it is greater than that of the previous and coordinate that we have seen, if that is the scenario, then we are increasing the value of arrow count and we're updating the value of prev as well, right? That would be points I1, right? And we'll be doing this, and at the end we are simply returning the arrow count, right? So I hope that is clear. Thank you so much for watching this video, guys. I have provided the code even in the description, but I believe if you are clear with the things, if you are clear with the logic, you will be able to implement it by yourself. Don't forget to share and subscribe my channel. Bye bye.